Before I'd like to get started, one, I do want to direct you to the front of the room where this is typical of setting up an objective and drill every single day. So if you just want to give that a quick read as I go around and give my thank yous and regards, because without this would not be possible without the INDS department's phenomenal support from Dr. Montgomery, Dr. Freeland, Mr. McAlpine, my advisor, and of course Mr. Brown for all his inputs, and Ms. Sauter for just putting up with me. And then of course I need to give a thank you to the engineering department, to Dr. Spence, Professor of Practice for Mechanical Engineering, who without her support I would not even be in the position that I am today. And again, all those at the education department, Dr. Singer, Dr. Rakes, Dr. North Coleman, who are so busy, couldn't possibly take away from everything that all the good that they're doing for the current student teachers that are finishing up their second term in their student teaching, just like I am, that I'm taking one day away so I could be here with you. And then of course, thank you to all those that I work with, my mentor teacher, my principals, so Ruth Akers, Mr. Wecklein, as well as Dr. Bose for their continuous support in my endeavors, and I guess to my surprise, a wonderful job offer for next year. So I will be returning to my current school, which I'm very happy to announce that today. So thank you very much. With that, I would like to get started for the day. In the front of the board, very typical, every single day that I have students come in, write down their objective and drill for the day. Simply, I just ask for you to name and date a single sheet of paper that you were provided when you walked in the door, because you will need this for today, and I'll need this from you at the end of the day. Then as you are doing that, you'll notice there's a couple materials just located right in front of you. You'll be working in design teams for the day. You'll notice that you have a golf ball, roughly 16 inches of packing tape or masking tape, as well as a single sheet from the local Afro-American newspaper. What I'd like for you to do is just close your eyes and imagine your masking tape, your golf ball, your newspaper, all coming together right in a space right in front of you. And just somehow erecting out of all those materials is a structure that is lifting your golf ball inches, maybe feet, maybe a couple more feet off of the table. I want you to think about, what do you see happening to those materials in front of you? Is there a property about the paper or about the tape? Or maybe a destructive property about the golf ball that would either help or possibly hinder you being able to support a golf ball the highest you see possible off of this table, right in front of you. Go ahead and just give it a couple more seconds of thoughts. When you have an idea, go ahead and give a sketch. Put down a sketch on a piece of paper in front of you. Or if you're not artistically inclined as much as I am, give a couple descriptive words. Is there something about the paper that you see could help you rise that golf ball off of the table? So I'm looking for a completely freestanding tower that's going to be able to hold this golf ball up from the table. No, you're not hanging it from the ceilings. No, you're not throwing the golf ball up in the air and hoping it stays there. So you will notice that there's only a few limited amount of materials on the tables in front of you. That means I'm going to ask you to work as design teams. You're going to have to figure out how to do this together. So what I would implore you, but for the sake of time, I'm not going to ask you today, is you would then at this time communicate with your partner or partners of how do you think you would be able to solve this challenge in one class period? And of course, extra credit goes to the one that has the highest standings hour. This is what I would consider to be the start off to what I consider to be an engineering classroom, and an example of what I do on exploratory days with my students. It's one that incorporates engineering and technology in the classroom that could potentially open the doors for our students as well as for the future of education. What you see in front of you is the current ABET definition of engineering, and ABET is an accreditation agency for universities that partake in teaching applied sciences or engineering. If you manage to get through that whole phrase, good on you, but I simplified it for you. It's basically engineers use math and science to make the world a better place. But what is engineering but some vast field? It's in itself, it's complex and interdisciplinary. From past times, it all started from this idea of civil engineering and then branched out into many different forms of specified interest, dozens, if not. All united in the same disciplinary concept of engineering, but in itself, every different field interacts with a different discipline, making, again, engineering itself very complex and interdisciplinary. So it kind of leaves us confused. How can we expect to have this as a curriculum in schools and make it something that, that students can understand? You need to find the common factor. And the common factor is the students themselves, or you, or professionals. I'd like to refer to them as technicians or engineering technicians. What you see up here is just a brief summary of some of the specific applied jobs that engineering technicians can have. While they can have tons of different tasks in whichever field that they go into, there's one thing that unites them all together, and that's communication. What these graphs show is when a poll was taken with current engineers and advisory boards. In the top 2 percentiles for both the skills required for technical practice as well as the frequency of different elements of problem solving, it involved communication and team problem skills. So what employers want is a combination of communication and students that demonstrate the ability to learn and to demonstrate the ability to want to grow and use different communicative needs. As a result, I developed the following question. And that is, how can the disciplines of communication and engineering be used in education to enhance the overall classroom experience for students and be used to stimulate more meaningful and student-centered learning? This is a question that involves a lot of thought. A lot of thought. This is a concept map that I developed as I was moving through the interdisciplinary program, and what really truly reflects what I consider engineering education to be. But in order to simplify it for you, not that you can simplify education, because when it comes to a teacher, you need to consider every single aspect that can help students prepare to be the best that they can be, because you're dealing with other people's children. And to me, that means you need to consider all factors. So what I did take is what stood out the most to me in engineering and communication and applied them into education. So for example, this theory, experimentation, and technology from the engineering side, and how does that really relate and compare to working within teams, having specific roles and dynamics that you need to adhere to make positive and effective communication in an engineering classroom. those components is where I was able to find common grounds through means of extension, which essentially means that I am taking concepts from communication and engineering and applying it to the education discipline specifically. So what I'm saying is communication is able to generate success in tandem with engineering applied into the education discipline. And engineering is what's giving us the tools to make this possible. And engineering innately enables you as a teacher to cater to the multiple intelligences of a student and establishes an atmosphere where cooperative learning can happen. So using those in tandem is able to make basically a good, successful communicative classroom. The bridging technique that I chose to use was the bridging the explanation action gap, where one discipline defines a problem. What we know today is looking at what leading technician specialists say is if we continue growing as a nation, we're not going to have enough jobs to support the continued growth in the engineering field. So what I say is education, that there lacks something in education. That's because students are not being able to be prepared or have enough qualification to make the decision that they want to go into an engineering field. So it all starts with preparing students now. And then, so constantly in integrating this communication engineering principles, I'm answering that question in education. And then education still further exists as a way for me to check to make sure meaningful student learning is actually happening. The methodology that I chose to use is basically this term of agentic engagement, which was the whole purpose of communication, bringing communication into the classroom. By giving students an ability to share what they're learning, it gives them a stakehold in what they do in the classroom. So what I have here is behavioral engagement, emotional and cognitive engagement are things that happen on an everyday basis in a classroom, which based off of an engineering classroom, I was able to establish those predecessors. But with communication, I was specifically able to make cognitive engagement happen, where students are participating in their educational experience and are able to relay to me as a teacher and to their peers what they are learning. And this is all in hopes of developing a metacognitive thought process for these students where real and true learning can happen. So my process involved, starting ever since I came to UMBC, building my competence in my engineering profession, or excuse me, my engineering field, as well as in my educational pedagogy, eventually leading myself to interdisciplinary studies where I was able to combine everything I've learned into a single focus in order to develop this question. What I did from there is I developed a unit plan that I would specifically implement during my student teaching phase. So currently this year. Okay.
Now, I can ask you if you could possibly, within 30 seconds, wrap this up for the rest of the talk.
Sure.
Okay.
Yes. This is the design process that I would use for my students, communication being the sole focus of communicating between every single step. What I had students do was participate in a challenge where they had to light a 0.4 watt light bulb for 15 seconds, and they had to use a renewable energy source. So through many design challenges, we were able to research and be able to identify how each individual team, so they would work in teams to solve this challenge, would answer the question. I evaluated based off of the student learning outcome, which is basically on nonverbal and verbal evaluations. Students plus communication can move to a non-linear growth in student learning. And I evaluated. Currently, I'm at a 70% effective rate for oral presentation. I have one more evaluation to go because they present on Wednesday. And then my design journals, which I have them keep on an everyday basis, I'm already at a 90% effective rate. So students are showing that they are developing the skills that they need to communicate. Start STEM early. Leave you with some quotes. There's nothing like a dream to create the future. And if I could have an audience member just read the second, please.
Education is the passport to the future, for tomorrow belongs to those who prepare it for today.
So what can you do today? Thank you.
Questions from around the room?
Yes, ma'am.
Yes. Can you passed through this and I picked up some sense of the meaning, but could you kind of give me a summary or capsule definition of agentic engagement?
Yes.
And also an example, perhaps, of how you employ that in the classroom?
Sure. So agentic comes from the social cognitive theory that we as people have a place or have a reason to believe what we're doing. So they have a personal stake in what we do as people. So what I'm using with the term agentic engagement is having students being able to take ownership in what they do in the classroom. It's their decision to want to come in during flex time or come in during school to work on their project because they know that they can do well and they can succeed, but they need to make the choice that that's what they want to do. Did that answer your question?
Yes, and is your
Okay.
example that you have this flex time that they can come in, or is there something?
That would be an example of what students have decided they want to utilize. Because of my unique situation in the school, we have flex time available to them, but it's no similar than just coming before or after school to work on a project. But there are examples on in-class time. When you're agentically evolved, you decide to make the decision, no, I'm not, okay, I'm having a bad day, but I'm not just going to not participate because I know participating is going to be able to be beneficial to me for some reason. And that reason may vary for students. I'll take Ms. Lynn.
There's an assumption here, good job, thank you. There's an assumption that people understand what communication means.
Yes.
I wonder what you mean by that.
Okay. So I think communication means being able to, one, yes, communicate or deliver a concept effectively, but then there's process that leads up to being able to do that. I consider communication being a method that needs to be enacted in a classroom. For me as a teacher, I need to demonstrate to my students how it is that you do talk to someone. How do you communicate to reach a goal? And then when it comes to specifically evaluation, yes, I'm doing it on very objective means, but there is an evaluation that I would do as a teacher. Where did I actually see specific student growth when it comes to communication?
I thank you, and for the sake of time, I'm afraid we're going to have to move on to our next speaker, but thank you once again, Mike.
Okay.